Understanding MAP, MAF, and throttle data is essential for diagnosing engine problems. In this lesson, we'll show you how these sensors relate, how the ECU uses their signals, and the diagnostic strategy that leads to a solid answer instead of sensor guessing. The ECU uses manifold absolute pressure, mass airflow, and throttle position to cross-check if engine airflow makes sense. Before a fault, these values follow an expected pattern. Opening the throttle lets in more air, which both MAF and MAP should reflect. A mismatch points to a fault in a sensed value, wiring, or a mechanical system problem. To interpret fault clues, compare scanned PIDs under a fixed condition. For instance, snap the throttle open. MAF and MAP should both jump, and the throttle PID should report near wide open. If MAP and throttle agree but MAF is low, suspect a bad MAF or air leak. If all disagree, check for wiring, sensor ground, or even mechanical faults. Always relate scan values to the real condition before chasing a part. If MAP and throttle agree, but MAF is suspicious, try a direct voltmeter or scope reading at the MAF or check for unmetered air leaks. If MAF and throttle match, but MAP is odd, confirm MAP ground and power. Use PID comparison to drive circuit tests, not just replacement. Always use scan data disagreement as a clue, then prove it with a measurement or by recreating conditions. One sensor showing a strange value doesn't mean the sensor is bad. Don't swap MAP, MAF, or throttle parts before confirming with physical tests, comparing related PIDs, or checking for shared ground or power issues. Trusting a single PID leads to misdiagnosis and wasted time. Always cross-check MAP, MAF, and throttle data, relate them to engine conditions, and use targeted tests for proof. Matching PIDs point to likely good sensors. Disagreement unlocks the correct test path. Sensor guessing wastes time, but data-driven diagnosis leads to the real fix. Thanks for watching. Keep practicing PID comparison and data verification, and you'll be able to solve complex airflow sensor faults with confidence every time.